Good evening and welcome to today's live webcast of a Q&A for the Honkster Aerospace past projects and future projects. I'm joined here by Philip, the head engineer and project lead for Honkster Aerospace. How are you doing today, Philip?
Oh, hello. I'm doing pretty well today. How are you?
I'm doing good as well. So today we're going to recap on all the past Funkster BTM 1 through Funkster Model 2 and all the kind of future and past changes in the actual model throughout today's webcast. And we'll be answering your questions in chat and in the Discord. So yeah, let's get right into it. So first question I think I should say to begin with is what are your current and future goals for Honkster Aerospace?
Well, currently our main goal is to develop a functioning solid rocket motor that has components made out of printable or 3D printable material. Thus, it will allow to lower the cost and and also make them much cheaper and also easier to make.
So yeah, we know you've been working on the Funkster and now the Pluton. So could you kind of tell us about the classification of these motors and just give us some explanation behind why you decided to create them? Well, you just mentioned why, and just kind of a bit more information in the classification of the motors themselves.
Yeah, so we are just a small group of interested people in space, and we decided to make those motors, and also to the motors you need to use them for something. So we decided to make our own rocket called Pluton, which was suggested by one of our Discord users, and this also started a new milestone for us, which made us think about whole new things we could work with, we could improve, and maybe made our own versions.
Awesome. So, if you've been on any of the past webcasts before and you're just tuning in today, remember you can ask questions in the chat here, live on YouTube, and also in the Discord as well. One of the video editors here just popped up in the Q&A chat, so try and find their message and you'll be on the right track to ask any questions today. So if you've been on any of the past streams before, as I was saying, you do know I say over and over again when I comment that testing to failure is how you learn. If you're not failing, you're not innovating enough. And that's something that throughout the process here, we've seen happen quite a lot. So let's move on to, firstly, let's get right into it. So Fonkster BTM1. Should we have a little view of that?
Yeah, so what you can see on our stream right now is the view of grain of Honkster BTM1. This was our first motor. It was very, very not engineered motor. It was really just one pathfinder to just see how it could resist heat and if the PLA or any 3D printable material could be an option. So we begin with PLA, which is a worst option for making something that's supposed to be strong or something that's supposed to be heat resistant. But after the static fire, we managed to make a point that we can use this, even though the BTM1 generated a really little thrust, just about 3 to 6 or 8 kilograms. It's really hard to say reliably because our load cell was very bad at the moment. We really did not have a lot of sensors. All we could mainly observe was like the simulations and the videos. And as it makes sense, you probably don't get a lot of thrust information from the video. So it did not generate a lot of thrust. The chamber pressure was low, but again, this was not supposed to be a good motor at the beginning. So it just fired, and we could observe how the screwable nozzle with threads could work, and mainly if the PLA or 3D printed materials can can resist this heat. So what we found out was that they definitely can, even though it's far from the best option, and we knew that when we are going into making motors from 3D printed material, we won't really get far until we manage to create some shortcuts or something that will allow us to make them strong and reliable and also generating a lot of thrust. So yeah, so it was this first one was just to show how the heat resisted, and if it did not blow up just on the first time, the nozzle was very overexpanded. That's why it also generated so little thrust. But still, it burned for a good 6 seconds with this thrust generation. But it was, this was not supposed to be even close to being final design. And you can see that this is the nozzle. It did not erode it that much as we expected. We expected it just to be burned and everything. But it survived and totally worked, even though there is some charcoal there of the burned PLA. But still managed to survive. This is from how the nozzle looked from the front. And this is the body. Yeah, so it survived really well. It survived more than we expected it to. And you can even see that there was less than 1 millimeter of eroded material, which made it really good point that the heat is not an issue. And even on the Discord server, or people that commented said, how are you going to solve problems with heat? So I always replied after this static fire, so until we have heat issues, which turn out not to be a problem, we won't solve any heat or make any new or add any new stuff to make it more heat resistant. You can also see this is the cross section of the body, and there's so little material eroded. You can see that there's black things all over the walls, but that's just from the hacksaw. Otherwise, it survived very well. Yeah.
So whilst we're on this kind of topic, just a quick question as well, is what type of fuel do these motors use? So what kind of chemical compound is it that are in these solid rocket motors, and how does, as well, whilst you're talking about the heat as well, a question from Discord at the moment is this relates to the heat kind of thing as well. So is there any plans to use steel or aluminium instead of PLA or ABS?
Well, yes, we plan to use these materials for other missions, or, well, it's not really a mission, it's just like new models of our motors. But we also, on the Honkster Model 5, which will be our upcoming motor, we will use a steel nozzle just to prevent this erosion you could saw on the BDM1. And yeah, if like we don't plan to use the steel on a body, because yeah, as I said, our main goal was to create the motors from plastic, and we still kind of want to hold on it, even though it's not completely plastic, but still having a plastic body can still reduce a lot of weight and even cost.
Awesome. So I know when watching the BTM1 static fire, the igniter failed on the first attempt. So is there any reason behind this? How did you learn from that, and what kind of
elements did you... the thing is that the igniter actually did not fail. It was not failed that it was not a thing that igniter was not the thing that failed. It was the total ignition. The igniter fired, but it did not light the motor. So yeah, we then proceeded to use burn powder. Basically, as you can see from this image, the grain is just hardened propellant, or SPNIO, which is short from sugar and potassium nitrate, and the percentages of 65 to 35 oxidizer to fuel ratio, which is commonly used one. We also added 1% of iron oxide, and also it's not melted. A lot of people melt this. We were not able to melt it due to some issues, but then how we fixed the ignition, that we scraped or added a little bit of the powdered propellant into it and ignited the powder. And the powder is much easier to ignite than a whole solid. So after we ignited the powder, then the powder lighted up and managed to ignite the entire motor, making it successful static fire.
Awesome. So probably another question we should ask for this thing is, what data did you get from this static fire then?
Excuse me, I did not heard the question.
So it was, what data did you get from the BTM1 static fire?
Oh, yeah, so this was again ask thing. So we did not manage to get any good data from this. All we just learned is that that it can resist the heat, and the PLA could be used, but it's not the best option still. And we also learned that we can make this work, and from the observations, yeah, so even this was our first static fire, we did not get a lot of data. It was really not a lot.
Alright, so is that everything you've got to cover for BTM1, or is there anything else you'd like to talk about?
Well, probably not. We decided to make the second one much smaller, and in the nozzle to test the thrust and how much we can improve on the nozzle. But yeah, that's to the second one. But first, probably we should play the footage of the first one.
Yeah, so let's watch that now.
Yeah, so I'll quickly. So we got a stream camera. We have a security camera. This was not really anything we considered, but still we got a security footage, so from the upside. And then we got our wide angle camera. This test was still performed in an area where people live, which was not great. Then we decided to move to the other test sites.
3.
So
Ignition sequence start.
So this is the fire. The flow of the nozzle looks very not
Engine
stable, but that's really because the camera and the shutter is a rolling shutter, and this caused the flow to look a bit wonky. But from this angle, you can see that the flow is not really that bad. However, it still was not generating a lot of thrust. And it also knocked out our measurement thing. It was not really secured. As I mentioned, this was our first test. We did not really expected much from it, and even though it fired, it was still a great thing. Yeah, so it was nice first try. It kind of worked, kind of did not, and yeah, it was a success, considering that it worked. Like, the thing did not blow up and did not melt it down, and yeah, so there was not really a lot of stuff there. It just worked. So yeah, we considered it success, even though we did not get a good data, but we proved that the PLA could work if we managed to lower the chamber pressure as on the next tests.
So yeah, I think that's a good time to move on to BTM1 static fire. So have you got a video to start us off for this segment?
You mean BTM2? Yeah.
Sorry.
Yeah, no problem. So yeah, so this thing just blew up. It completely obliterated itself. The thing that survived was
7,
just
6,
the thing that survived that was really just the bottom. And fun fact, the nozzle blew up so far away that we could not find it. And yeah, it was fast explosion. We did not expected it to blow up that hard. We maybe like it will torn apart. But yeah, this was very strong, and it was cool to see that, because, you know, it turned out from making rocket engines to making grenades.
So you touched upon then what went wrong. So I'm guessing let's talk about the purpose of this this motor then. Was this from
Purpose.
BTM1, was this taking on the kind of things you learned from BTM1 and bring it onto BTM2 then?
Yeah, so the thing, we actually fixed our load cell, and we tried to get some good thrust data, so we, for some stupid reason, made the nozzle too small, from the simulations looking back on it, it was really stupid move. There was like 400 psi chamber pressure in that motor, so I mean, I'm not really surprised it blew up. Yeah, and also it's very hard to do these simulations because, you know, we don't have some fuel that is well monitored, and as we are using open motors as amateurs, normal people are using, so we used it as well. So yeah, it blew up basically, and it destroyed our load cell. And
yeah, that I know that was a pain for the company itself. So after this this run, as we should say, what were the steps in ensuring the safety of all personnel and stuff, and before and after kind of thing?
yeah, before there was not really much safety on these two motors, even though it was pretty safe. The motor was covered and as you can see, concrete bricks from all the sides except the one that we were streaming from, and the cameras were all secured. There were no people around. We made sure that there is no one there, and we actually reconsidered redesigning it completely, which we did, and then we moved to like fields and all this, where we actually asked the owners and informed them, so we are not doing anything illegal. So yeah, we then moved to the other stuff where we blow up these things.
Yeah, so Model 1 is the next one on the list.
Yeah, a lot of things failed there, but not as much as on Model 2. So basically what happened here is that we had good ignition, but again the thing overpressured and blow up. We completely underestimated the chamber pressure, and it detonated. It was not like the first one, there was a shockwave, so we can now say that we detonated things. Yes, on this angle you can a little bit see the shockwave as it passes through the grass, or I mean the dirt. Yeah, but it's not really there. But again, you can see that we put much more safety into it. It was all covered in concrete. Then we were on open field, without any grass. So if there was a fire or something like that, uh, the nothing would catch on fire. I can see in chat that someone says that I don't know what detonation means. Well, detonation is that if the material detonates, I believe, or in creates a shock wave, and otherwise it's just a deflagration. So, like the BTM1 was, the TM1 was a deflagration, and the BTM2 and TM1 was a detonation because the shockwave was present, and yeah, it created a shockwave. So also, yeah, we had something called clogged nozzle that the fuel, unburned fuel, was pumped through the nozzle, not burning and clogging it even more. That caused it to just explode even more, not release a lot of things. You can actually see it on the slow-mo. So you can see, like, right after the ignition, after the smoke starts coming out, there's a lot of unburned propellant falling off, and then the motor, then after all of that material gets pushed out, it just blows up, and the nozzle was again underexpanded, and it was total failure. There was nothing really successful about TM1, but we are also experimenting with these rods, which turn out not to be good, much better or safer things. And yeah, it just blew up again.
So if I remember rightly with this test, this was the first time you testing the use of support rods in the motor, and then I also understand that you had a few issues with the test stand during this test.
Yes, so until then we really did not even consider it a big test stand. And yeah, so after that we could see that motor moved before it, and it was not really good. Yeah, so we are using just tape to mount it because we did not expect the thrust from it, and we just really expected it to blow up because we are experimenting with how much pressure the thing can resist. We're slowly expanding the nozzle, and with doing simulations, we each time calculated what would the chamber pressure be. So then we made these 2 tests of models, which were just to see how much pressure it can resist, and then we could know if we even more have to open the nozzle or if we are right at the spot, which we did not manage to get to.
So yeah, that brings us on to TM2 then, doesn't it? So as you said before, this was a practical finder. So yeah.
Yeah, so this was our last test. It was done a few weeks ago, and it really is just so we would see that we expanded the nozzle even more. But this was even worse than TM1 because we were so in a hurry. We did not really have time to prepare, and also since this, even though it was much safer, since all of the energy got released into the concrete thing, you could see it explode, and also the thing concrete protection got obliterated as well, and damaging it. Yeah, it was again a big explosion. It was loud, but still we were not doing anything illegal on not our property. So the safety, no one was there again, and also all of the debris was collected, and multiple things happened here. Again, it's overpressure, that's the main thing. We also had a new test stand which we did not manage to test because the test stand ended up in a powder form. So this is how it went, and this was even worse because the thing exploded right away. This meant that the nozzle uh, got got stuck even before it got chance to fire, which means there was really not a lot of exhaust, and it just blew up. Also, the strange thing is that it did not ignited. Uh, it did not ignited a lot of fuel, so we managed to find that even though we had the thicker walls and bigger nozzle, we still managed to get much more pressure out of just the smaller fuel. As you can see, there's a lot of brown powder on the test stand as the fuel, and it's not burnt.
So yeah, with the explosion here again, I'm assuming you took the safety procedures that you learned from the beginning of the test program and incorporated them now to ensure that everyone was safe during all the static fires.
Yeah. Yeah. Well. Yeah. It was all safe. We were in a safe distance. Nothing was really damaged except our safety things, which got blew up. So you can see again, there's a lot of powder propellant running off, which is not good. And you can even see that the nozzle is really big. It's like 16 millimeters wide, the exit, and the throat diameter is around 1 centimeter, which was still too small for it. And yeah, then we managed to work. Then we decided to stop because we don't want to destroy our every single motor. So yeah, we were doing a lot of stupid mistakes on this ones, but then we decided to go further and making some good progress by switching the materials of the nozzle. Like that's the biggest change probably, and we managed to get people that will help us make a metal nozzle. One company that works with CNCs and just metal machining, and they managed to make us a new nozzle for our TM5. We basically skipped some motors that were just supposed to again expand the nozzle, because there was not really a point in just staying stuck on this one spot with our motors just blowing up. So yeah, then we managed to also change the material from PLA to PETG. Also, we got a suggestion from some talented people on the Discord that we should use polycarbonate. Yes, we will definitely use that in the future, and also we will wrap our we will wrap our body of our motor in a carbon fiber and Kevlar, just to make sure that it doesn't really explode, and even if some overpressure occurs, those Kevlar will be able to stop it. So yeah, so we managed to stop there and just move to our fusion motors.
Yeah, so this brings us straight onto the future plans. So obviously you've started to describe Pluton, which is your upcoming launch vehicle.
Yes.
The model launch vehicle, as you can see on the screen here. So one question we've had from the Discord is how high will I can't actually speak today. How high will Pluton fly?
Yeah, so we are making our motors really for first we have to make this for first we want to make low altitude versions for both motor and rocket. So it will be really just some small tests, not really a test, just to see if it can fly, if the aerodynamics is good. So what you can see now is the first our rocket design that was really quickly put up together just to get some first piece that we could start off with. and then we'll slowly just adjust some things. And yeah, we got from the simulations like of the ISP of our motor, which is of the TM5, if it doesn't blow up again, this first low altitude test should be able to fly to height of 130 meters, which is not high, and it's not high because you need a certificate to fly any higher, which we don't really want to get early on, because if we manage to change our design completely, we don't want to just feed people with designs and designs and designs that don't really get some space, and yeah, they won't be useful.
Just a quick reminder to everyone in the YouTube chat and in Discord, remember to ask your questions in the chat and in the Discord channel appropriate for today's stream. Some more questions as well. So you said about the CNCing of the new nozzles. Is this going to be a permanent way forwards, or is this just a temporary solution?
No, it's definitely permanent. I totally agree with people that saying that metal is actually a way to make motors. But yeah, so if you make just everything that everyone else makes, what's the point, you know? If you don't innovate. If we manage to make these things from PETG or polycarbonate or just basically any 3D printable material, it could be much better for anyone, you know? We could probably sell those designs or just give them to people that are interested in things, and they can just print them home and just get nozzle again, which they can just give to some contractor or any company they really want to get the nozzle from, and they can just use the motor. The first low altitude one using the and also I forgot to mention, we are changing the propellants. We won't be using our own. We'll be using KNSB, which is a propellant not made by us, which is a propellant made by Riker Naka, and yeah, we're not really taking any credit for it. It's just a propellant that is well monitored, and it's good to use. And with this propellant and our motor, we will be able to achieve 400 Newton seconds of impulse, generating thrust of 20 kilograms for 2 seconds, which is good for low altitude, not good for a high altitude. First, we are just experimenting with this lower sort of impulse thing, just so we can make sure that it works, and we again have something to work on and improve. And and also
Matt in the YouTube chat asks, will you ever move away from solid fuel types?
We are planning to get a working hybrid rocket motor. It's really just after this solid rocket motor is completely done with, and I plan to work on it with one of our team members. Well, I don't know really. And we don't really want to go on liquids any close, because it's just pain to do, and it's really hard. And I also see one question: is the name Pluton inspired by Photon, which is rocket I'm working on? Well, no, and we got a Discord user that DM'd us, which I probably won't read the message because it's still DMs, but after we made our post of searching for people that could help us, he DM'd me that he was thinking of it, and he gave us this idea, which I really liked, and that's why we used it as a name for a rocket.
Awesome. So we'll be taking a few more questions from the YouTube and the Discord chat. If you've got any questions, feel free to put them in. And is there anything else you would like to say, Philip, before we end the webcast today?
Well, maybe that Yeah, the motor, the TM5, which we are working on, is actually a class that we got a lot of people just telling us that it's bad thing, and we really aren't making a bad size to thrust, but actually motor we are making is a class I, which is the impulse from 320 seconds to 640 newton seconds. And yeah, so this, you can't even normally buy these motors, so I believe it's not really that bad as some people say, because I don't know really why the people, but yeah. So on this picture, this is a nozzle, or just cross section of the metal nozzle we'll be using. We also have the version with dimensions, but yeah, since it's not final, I really don't want to release any specs on this. And this will be the body of the motor. We also improved with the pressure handling, and as some clever people suggested, having like a steep, well, having a square type of ends on the end of the combustion chambers will create much more stress on the body itself. So that's why I went with this half ball shaped design. Yeah, so we are working on these things currently, and we hope to get it working.
Yeah, so that was a good insight into what your aerospace company are planning to do in the next few months and the kind of way forwards you're looking at. So I think this is a good time to kind of introduce and say thank you to some of the team members who have helped create this. So you've obviously got Philip, who is the head engineer and the project lead for this project. Me, who is the graphic design, stream designer, stream templates, and video editing, thumbnails, and everything to do with all the graphic design. So thank you to him as well. As well as this, we have Oliver, who is the stream administrator. He does general help and just administrates all the streams and does all that kind of stuff. So thank you to him as well. Also, as well, we have Milt for designing the launch computer and TVC for the future projects. And yeah, so we've got Jerky as well for general help and all of the moderators on the stream and on YouTube. So thank you to everyone for their contribution to this project. So is there any closing remarks you would like to say, Philip?
Yeah, well, thank you very much for your awesome web hosting. And thanks to everyone who said something in chat, or for the people who watched. And I hope that some people will change their minds about about us, and that they will maybe believe that we can do it, because it's somewhat, yeah, we work on a like public base, and we really want to satisfy as most people as possible. And not just that, we also want to make our things work. That's why we giving insights to all of our projects, and yeah, that's why we also are asking always for people to help us, and not just people to just hate and swear. So yeah, well, thank you again.
I think we have time for one more question. It's not really a question, but in the chat it says about using the flat end caps on every Rocketeer uses that, and I just want to say that pressure tanks use the kind of arced at the edges, like the half a golf ball shape kind of thing, because that is it holds more pressure than someone with a flat end cap. And if you if you look over to Starship in Boca Chica, you can see that the bulkheads there, they are arced over, and that is to do with the pressurization. So that answers that question. And yeah, is that everything we would like to cover today, Philip?
Yeah, probably. Well, thanks for everyone. The person said that the pressure is something different. Well, not at all. We are just saying this about a pressure. No.
Yeah. So the whole reason this the motor here is arced as well is due to the combustion chamber pressure. So that is why it's arced now. Similar to that is the best way to hold pressure in any vehicle.
Yeah, and also solid rocket motor is still a giant pressure tank that's slowly releasing all of its pressure to generate thrust and releasing gases so it moves opposite, yeah, as the Newton's law says. Yeah, we come with the change of grain geometry. We come with that, and we also have, we have the simulation accurate because we come with that. You can also simulate this round ends. Yeah, well, thanks for everyone participating here, asking questions, commenting. And yeah, so this will be probably end for today's stream. It's been running for a while.
Yeah, thank you to everyone who's tuned in today, and we'll see you on the next stream.
All right, so thank you, Elliot, for having this awesome webcast, and for having this great commenting. All right, so